Hello students, welcome to your channel Parivartan Physics. See, we are solving 5 mark numerical problems from model question paper 3 of academic year 2024-25 in this video. Model question paper 1, model question paper 2. ಈ ಎರಡು question papers 5 marks numerical solve ಮಾಡಿದ videos already upload ಆಗಿದಾವೆ, and this is the third video on model question paper 3, right? So there were 3 model question paper released for this academic year. So all 3 model question paper numericals ಗಳನ್ನು ನಾವು ಈಗ solve ಮಾಡ್ತಾ ಇದ್ದೀವಿ. Right? Okay. So if you want to watch those videos, the link is present in the description box. Please watch that video also. And if you like the content of this channel, please don't forget to subscribe the channel and share the channel with your friends. Right? Okay, let us begin the video then. We'll start with numerical problems from model question paper 3. See, model question paper 1 ಮತ್ತು model question paper 2. ಈ ಎರಡು model question paper ಒಳಗೆ ನಮಗೆ one model question paper there was a numerical on electric charges and field. Another model question paper electric potential and capacitance. E model question paper namak electric potential and capacitance mele first numerical adare, right? So there is the possibility of getting 5 mark numerical from first chapter also or from second chapter. First chapter daginda niಮಗೆ derivation bandre second chapter daginda numerical ಕೇಳ್ತಾರೆ 5 marks ಇದೆ. First chapter daginda numerical ಕೇಳಿದ್ರೆ second chapter ಒಳಗೆ ನಿಮಗೆ derivation ಕೇಳ್ತಾರೆ. Right? Okay, that all I have told, I have explained that way of setting the question paper as well as guidelines of question paper in the video in which I have explained the simplified blueprint. If you have not watched that, please watch that video also. You will get to know how the questions will come. Okay, let us start solving the questions then. See, okay, the first question is 3 capacitors of capacitances 2 microfarad, 3 microfarad and 6 microfarad are connected in series. More capacitors series ಒಳಗದಾವ. Determine the effective capacitance of the combination. Okay, effective capacitance find ಮಾಡಬೇಕು. Find the potential difference across 6 ohm capacitor if the combination is connected to 60 volt supply. See, there are 3 capacitors. ಈಗ ನಮ್ಮ capacitors ಯಾವ combinations ಒಳಗದಾವ್ರಿ? Series ಒಳಗದಾವ. ಈಗ series ಒಳಗೆ capacitors connect ಇದ್ದಪ್ಪ ಅಂತಂದ್ರೆ effective capacitance. If there are 2 capacitors connected in series, effective capacitance will be C1 into C2 divided by C1 plus C2. 2 capacitors in series. 3 capacitors in series idduppa andre formula C1 into C2 into C3 divided by C1 into C2 plus C2 into C3 plus C3 into C1, right? So this is the formula to calculate effective series capacitance when 2 capacitors are in series, when 3 capacitors are in series. Now we have 3 capacitors in series. So let us calculate the effective capacitance of 3 capacitors in series. Right? I will write it as CS is equal to C1 into C2 into C3 2 into 3 into 6 into micro 10 raised to minus 6 into 10 raised to minus 6 minus 12 into 10 raised to minus 6 minus 18, right? So this will be 10 to the power minus 18 divided by C1 into C2 2 into 3 will be 6 micro will be 12. Okay, C2 into C3 3 into 6 18 into 10 to the power minus 12 micro, right? Plus C3 into C1 6 into 2 it will be 12 into 10 to the power minus 12. Okay, so I will get it as 2 into 3 6 into 6 this will be 36 into 10 to the power minus 18 divided by see here I will get it as 6 plus 18 plus 12 and I will take 10 to the power minus 12 common. Okay, so this will be 18 plus 2 will be 12 will be 30 plus 6 will be 36. So in the numerator 36 into 10 to the power minus 18, let it be as it is. This is 36. It is sum namagu 36 ಆಗ್ತದೆ. 36 into 10 to the power minus 12. Correct? So 36 and 36 will get cancelled. Minus 12 from this, minus 12 from this will get cancelled. What will be the remaining thing? 1 into 10 to the power minus 6. This much will be the capacitance, or I can simply write it as 1 microfarad, right? So this much will be the effective capacitance of 3 capacitors which are connected in series. Next, question number B another, find the potential difference across 6 microfarad capacitor. So you ಮೂರು ನಮಗೆ series ಒಳಗದಾವೆ. ಇದರದೆ ಇಲ್ಲೇ ನಮಗೆ 6 microfarad ದ voltage ನಾವು find ಮಾಡಬೇಕು. What is the voltage across 6 microfarad capacitor? Okay, these are the 3 capacitors connected in series, right? And they have connected a 60 volt battery here. 60 volt the battery namu connect madidare. Okay, this is of 2 microfarad, this is of 3 microfarad and this is of 6 microfarad. We know very well in series combination, charge on each capacitor will be same and voltage across each capacitor will be different. ಬೇರೆ ಬೇರೆ ವೋಲ್ಟೇಜ್ ಇರ್ತದ್ರಿ, ಚಾರ್ಜ್ ಮಾತ್ರ ಮೂರರ ಮೇಲೆ ಸೇಮ್ ಇರ್ತದ್ರಿ ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್ ಒಳಗೆ. ಪ್ಯಾರಲಲ್ ಒಳಗೆ ಏನಾಗ್ತದ್ರಿ, voltage will be same, charge will be different on different capacitors, right? Okay, see this 60 volt, ಇಲ್ಲಿ ನಾವು 60 volt ಅಪ್ಲೈ ಮಾಡಿದೀವಿ series combination ಗೆ. ಈ 60 volt ನಮಗೆ 3 parts ಆಗಿ ಡಿವೈಡ್ ಆಗ್ತದೆ. It will get divided in 3 parts, V1, V2 and V3. 3 parts ಆಗಿ ಡಿವೈಡ್ ಆಗ್ತದೆ. So V1 plus V2 plus V3 will be equal to 60 volt only. ಈ 60 volt ನಮಗೆ 3 parts ಆಗಿ ಡಿವೈಡ್ ಆಗ್ತದೆ. We know very well in series combination the voltage will get divided. ನೀವೇನ ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್ ವೋಲ್ಟೇಜ್ ಅಪ್ಲೈ ಮಾಡಿರ್ತಾರಲ್ಲ, ಆ ವೋಲ್ಟೇಜ್ ನಮಗೆ ಡಿವೈಡ್ ಆಗ್ತದೆ. ಈಗ ಇದು 60 ವೋಲ್ಟ್ ನಮಗೆ 20 ದಾಗ ಡಿವೈಡ್ ಆಗಬಹುದು, 10 20 ಅಂಡ್ 30 ಒಳಗೆ ಡಿವೈಡ್ ಆಗಬಹುದು. ಇಟ್ ಮೇ ಗೆಟ್ ಡಿವೈಡೆಡ್ ಇನ್ 20 10 30 ಲೈಕ್ ದಿಸ್ ಇಟ್ ಮೇ ಗೆಟ್ ಡಿವೈಡೆಡ್. ಸೊ ನಮಗೆ ಒಟ್ಟರಾಗಿ ಏನ್ರಿ, ಆ ಮೂರು ವೋಲ್ಟೇಜಸ್ V1 V2 V3 ಆಡ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಹೌ ಮಚ್ I will get 60 volt. In case if all capacitors were same, identical, then the 60 volt capacitor, 60 volt potential would have got divided into 20 20 and 20. ಮೂರು ಕೆಪಾಸಿಟರ್ ಸೇಮ್ ಇದ್ದಿದ್ರೆ 20 20 20 ದಾಗ ಡಿವೈಡ್ ಆಗ್ತಿತ್ತು. ಈಗ ಸೇಮ್ ಇಲ್ಲ ಅಂದ್ಮೇಲೆ ಅದು ಈಕ್ವಲಿ ನಮಗೆ ಡಿವೈಡ್ ಆಗೋದಿಲ್ಲ, ರೈಟ್? ಓಕೆ, ನಾವು ಲೆಟ್ ಅಸ್ ಫೈಂಡ್ ಔಟ್ ದಟ್. ಈಗ ಫಸ್ಟ್ ನೋಡ್ರಿ, ವಿ ನೋ ದ ಎಫೆಕ್ಟಿವ್ ಕೆಪಾಸಿಟನ್ಸ್ ಆಲ್ರೆಡಿ. ಎಫೆಕ್ಟಿವ್ ಕೆಪಾಸಿಟನ್ಸ್ ನಮ್ಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತದ್ರಿ, ಇಟ್ ಇಸ್ 1 microfarad, right? 1 microfarad. This much is the effective capacitance. How much is the voltage applied for that effective series combination of the capacitance? How much voltage we have applied? We have applied it as 60 volt. Correct? ಈಗ ನಂಗೆ ಟೋಟಲ್ ಚಾರ್ಜ್ ನ ಇಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬಹುದು. We know very well C is equal to Q divided by V. Correct? Then Q will be equal to C into V. Right? Here I will take effective capacitance. So effective capacitance is 1 into 10 to the power minus 6. Voltage is 60 volts. So I will get it as 60 microcoulomb, right? So charge ನಮಗೆ ಎಷ್ಟು ಬಂತಪ್ಪ ಅಂದ್ರೆ 60 microcoulomb. 60 microcoulomb. See, this is the charge on each capacitor. ಪ್ರತಿ ಕೆಪಾಸಿಟರ್ ಮೇಲೆ ಚಾರ್ಜ್ ಸೇಮ್ ಇರ್ತೈತ್ರಿ, ಬಿಕಾಸ್ ದಿಸ್ ಇಸ್ ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್. ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್ ಇರೋದ್ರಿಂದ ಚಾರ್ಜ್ ನಮಗೆ ಸೇಮ್ ಇರ್ತೈತ್ರಿ, ವೋಲ್ಟೇಜ್ ಮಾತ್ರ ಬೇರೆ ಬೇರೆ ಇರ್ತದೆ. ಪ್ಯಾರಲಲ್ ಒಳಗೆ ರಿವರ್ಸ್ ಆಗ್ತೈತ್ರಿ, ಪ್ಯಾರಲಲ್ ಒಳಗೆ ಚಾರ್ಜ್ ಬೇರೆ ಬೇರೆ, ವೋಲ್ಟೇಜ್ ಸೇಮ್ ಇರ್ತೈತ್ರಿ. ಕರೆಕ್ಟ್? ಓಕೆ, ಸೊ ಹಿಯರ್ ವಿ ವಾಂಟ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ V3 potential difference across 6 microfarad. Charge ನಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಾಗಿದ್ರೆ, how much it is 60 microcoulomb. Okay, we know charge, we know capacitance. Capacitance ಗೊತ್ತದೆ, ಚಾರ್ಜ್ ಗೊತ್ತದೆ, ನಮಗೆ ವೋಲ್ಟೇಜ್ ಬೇಕಾಗಿತ್ರಿ. So voltage V3 is equal to Q divided by C. Q divided by C3 ಅಂತ ನಾ ತಗೋತೀನಿ. Q divided by C3. Right? How much is Q? Q is 60 microcoulomb. 60 microcoulomb. 60 into 10 to the power minus 6. How much is C3? C3 is 6 microcoulomb. 6 microcoulomb. So micro 10 to the power minus 6, 10 to the power minus 6 will get cancelled. 6 ones are 6 tens are. So how much is the voltage across third capacitor? It is 10 volt. So voltage across 6 microfarad capacitor is 10 volt. Right? This is how we have to calculate the voltage. Correct? Okay, that's all about the first question. We'll go for the second question now. Second question is on current electricity. See, in all three model papers, second numerical is on current electricity only. So you are going to get a 5 mark numerical from current electricity, right? One current electricity numerical ನಿಮಗೆ ಬರೋದ್ರಿ. Okay, so make it perfect. Current electricity numericals ಗಳನ್ನು perfect ಮಾಡ್ಕೊಡ್ರಿ. ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ಮತ್ತು ಸೆಕೆಂಡ್ ಚಾಪ್ಟರ್ ಕೂಡ numерicals perfect ಮಾಡ್ಕೊಡ್ರಿ. ನೋಡ್ರಿ, ಫಸ್ಟ್ ಚಾಪ್ಟರ್, ಸೆಕೆಂಡ್ ಚಾಪ್ಟರ್ current electricity AC. ಈ 4 ಚಾಪ್ಟರ್ ನೀವು ಏನಾದ್ರೂ numерicals perfect ಮಾಡ್ಕೊಂಡ್ರೆ ಶೋರ್ ಶಾರ್ಟ್ ಯು ಕ್ಯಾನ್ ಅಟೆಂಪ್ಟ್ 2 numерicals. ಹೆಂಗೋ ಎರಡೇ ಸಾಲ್ವ್ ಮಾಡೋದ್ರಿ. ಔಟ್ ಆಫ್ 4 2 ಯು ಹ್ಯಾವ್ ಟು ಸಾಲ್ವ್. ಸೊ 2 numерicals ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಸಾಲ್ವ್, ರೈಟ್? ಈಗ ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ವೆರೈಟಿ ಆಫ್ numерicals ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡಿ ಆಲ್ರೆಡಿ ವಿಡಿಯೋಸ್ ಗಳನ್ನು ಹಾಕಿದ್ದೀನಿ. ಐ ಹ್ಯಾವ್ ಸಾಲ್ವ್ಡ್ numерicals ಆನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜಸ್ ಅಂಡ್ ಫೀಲ್ಡ್ಸ್, ಕರೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ 2 ಚಾಪ್ಟರ್ ಮೇಲೆ ಈ ಇಯರ್ 2024-25 ಅಕಾಡೆಮಿಕ್ ಇಯರ್ ಒಳಗೆ ಅಪ್ಲೋಡ್ ಮಾಡಿದ್ದೀನಿ. ಲಾಸ್ಟ್ ಅಕಾಡೆಮಿಕ್ ಇಯರ್ ಒಳಗೆ ಐ ಹ್ಯಾವ್ ಅಪ್ಲೋಡೆಡ್ ಆನ್ ಫಸ್ಟ್ ಚಾಪ್ಟರ್, ಸೆಕೆಂಡ್ ಚಾಪ್ಟರ್, ಥರ್ಡ್ ಚಾಪ್ಟರ್, AC, ರೇ ಆಪ್ಟಿಕ್ಸ್, ಇವೆಲ್ಲದ್ರ ಮೇಲೂ ಕೂಡ ನಾವು ವಿಡಿಯೋಸ್ ಗಳನ್ನು ಮಾಡಿ ಹಾಕಿದ್ದೀನಿ numерicals. ಯು ಕ್ಯಾನ್ ವಾಚ್ ದೋಸ್ ವಿಡಿಯೋಸ್ ಆಲ್ಸೋ. ಆ ವಿಡಿಯೋ ಒಳಗೆ numерicals ಬೇರೆ ಅದಾವ, ಈ ವಿಡಿಯೋ ಒಳಗೆ numерicals ಬೇರೆ ಅದಾವ. You will get enough numерicals to practice. You practice those numерicals, that is more than enough for you to attempt any type of question which appear in your annual examination. Right? Okay, let us go to the question. For copper, the number density of free electrons is 8.5 into 10 to the power 28 meter cube per meter cube, and resistivity is 1.7 into 10 to the power minus 8 ohm meter. Calculate the conductivity of copper and relaxation time of free electrons in copper. Okay. Mass of electron is given and charge of electron is given. What is given? Electron density. free electron density, we represent it by small n, right? Free electron density. It is 8.5 into 10 to the power 28 per meter cube. Istu namagu free electron density adu. Resistivity 1.7 into 10 to the power minus 8. Resistivity is given 1.7 into 10 to the power minus 8 ohm meter. This much is the resistivity given. Ohm meter, this much is the resistivity given. What they are asking, calculate the conductivity. Okay, we have to calculate conductivity, the first thing. Second thing, they are asking us relaxation time. Okay, relaxation time we have to calculate. See, we know very well by theory, by definition, conductivity is reciprocal of resistivity, or resistivity is reciprocal of conductivity, right? Therefore, the first thing what I have to calculate is conductivity, and conductivity means it is reciprocal of resistivity. So, reciprocal of resistivity. Resistivity kottidare namagu already 1.7 into 10 to the power minus 8. 1.7 into 10 to the power minus 8, right? So, we'll calculate this. 1.7 into 10 to the power minus 8 is given. So, I will take it as 1 divided by 1.7. It is 0.588. 0.588. This 10 to the power minus 8 na melgade tagondre, it will be 10 to the power plus 8. 10 to the power plus 8. So, this much is the conductivity. Conductivity namak istadare, right? So, we got to know about conductivity. See, what will be the unit? See, resistivity unit namak ohm meter ada. Hangadre idu 1 by resistivity irodrinda idu ಏನು ಇರಬೇಕು per ohm per meter, right? This much will be the unit of conductivity. Second thing, they are asking us to calculate relaxation time. Relaxation time. Relaxation time will get it in the formula of conductivity. Conductivity the formula ಒಳಗೆ ನಮಗೆ relaxation time ಬರ್ತದೆ. So conductivity the formula ಏನದ NE square tau divided by m. NE square tau divided by m. This is the formula of conductivity. So ನಂಗೆ relaxation time ಬೇಕು. So relaxation time is equal to conductivity into mass of electron divided by electron density into E square. Correct? Substitute the values now. Sigma, how much is conductivity? Conductivity is 0.588. 0.588 into 10 to the power plus 8. How much is mass? Mass is 9.1 into 10 to the power minus 31. 9.1 into 10 to the power minus 31 divided by how much is free electron density? 8.5 into 10 raised to 28. 8.5 into 10 raised to 28, right? In E square, E under charge of an electron, it is 1.6 into 10 to the power minus 19 whole square, right? Okay, let us solve this now. Idin ಈಗ ನಾವು solve ಮಾಡ್ಕೊಳ್ಳೋಣ. Okay, so we'll multiply this. So it is 0.588 into 9.1 into 9.1, that is 53508, right? So here I will write it 53508, 5.3508, right? Into ಈಗಲೇ ನೋಡ್ರಿ 10 to the power minus 8, 10 to the power plus 8, ಇದ್ರೊಳಗಿಂದ 10 to the power plus 8 ಹೋಗ್ತದ್ರಿ. ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಉಳಿದಿದ್ದು 10 to the power minus 31. 10 to the power minus 31 divided by, so this is 8.5 into ಇಲ್ಲಿ 10 to the power 8 ಹೋಗೈತ್ರಿ. ಸೊ 10 to the power 20 ಮಾತ್ರ ಉಳಿತದೆ ನಮಗೆ. Okay, 1.6 into 1.6. So 1.6 into 1.6. So this will be 2.56. 2.56 into 10 to the power minus 19 square will be equal to 10 to the power minus 38. 10 to the power minus 38, right? This much I will get. So minus 31 from this and minus 31 from this will get cancelled. How much will be remaining here? 10 to the power minus 7 ಉಳಿಬೇಕಲ್ಲ, 10 to the power minus 7, right? Okay, so first let us multiply these both. 2.56 into 8.5, 2.56 into 8.5, this is 21.76. So here I will write it 5.3508 divided by ಇದು multiply ಮಾಡ್ಕೊಂಡು 21.76 ನಮಗೆ ಬಂತು. 21.76 into, see here this is 10 raised to 20, 10 raised to 20, and this is here will be getting 10 to the power minus 7. ನಮಗೆ minus 7 ಬರ್ತದೆ, correct? So 20 minus 7 will be 10 to the power plus 13. So here I will continue. Relaxation time is equal to 5.3508 divided by 21.56, sorry 76, 21.76 into 10 to the power plus 20 minus 7. This will be 10 to the power plus 13. 10 to the power plus 13. Right? And now we'll divide this 5.3508. 5.3508 divided by 21.76. 21.76. So this will be 0.259. Sorry, 0.2459 into ಈ 10 to the power 13 ನಾವು ಮೇಲ್ಗಡೆ ತಗೊಂಡ್ರೆ it will be 10 to the power minus 13. Right? 10 to the power minus 13. So this much will be the relaxation time and the unit is seconds. Just ನಮಗೆ relaxation time ಇರ್ತದೆ 0.2459 into 10 to the power minus 13. That is all about relaxation time. Right? So we got how to calculate conductivity. First thing is we calculated conductivity and then we calculated relaxation time. Let us go to the next question then. See, the next question is again on AC. Model paper 1, there is a problem on AC. Model paper 2, there is a problem on AC. Model paper 3, there is a problem on AC. So current, electricity, alternating current. ಈ ಎರಡು ಚಾಪ್ಟರ್ ಮೇಲೆ you are going to get a 5 mark numerical. So AC ಮೇಲೆ numericals easy ಅದಾವ್ರಿ. Never ever leave it. ಒಟ್ಟ ಬಿಡ್ಲಿಕ್ಕೆ ಹೋಗ್ಬೇಡ್ರಿ. Practice all the types of questions on AC. You will surely get a 5 mark question on it. Okay. See what is given. A resistor of 50 ohm, a pure inductor of 250 millihenry and a capacitor are in series in a circuit containing an AC source of 220 volt 50 hertz. In the circuit, current leads the voltage by 60 degree. Find capacitance of the capacitor. Okay. This is LCR circuit only. LCR circuit adare. So let me take this one is resistor. This is capacitor and this is inductor. So this is a series LCR circuit. Series LCR circuit. You know, resistor is of 50 ohm. Resistor is of 50 ohm. R. Capacitance we don't know. That is what we have to find out. Inductance is given, that is 250 millihenry inductance. Voltage ನಮಗೆ 220 volt apply ಮಾಡಿದಿವಿ. Frequency is 50 hertz. Frequency is 50 hertz. This much they have given. We have to find out what phase difference ಕೊಟ್ಟಿದ್ದಾರೆ ನಮಗೆ. Phase difference is 60 degree. Phase difference is 60 degree and they have told that current leads voltage. Current leads voltage. Current leads voltage ittapa antandre we should know it is capacitor dominant circuit. Therefore here XC will be greater than XL. XC will be greater than XL. Now model paper 2 ಒಳಗೂ ಕೂಡ ಇದನ್ನ ನೋಡ್ಕೊಂಡಿದ್ದೀವಿ. When XC will be greater than XL, XL is greater than XC ಇದ್ರೆ ಏನಾಗ್ತದೆ? See, if XC is greater than XL, current leads voltage. If XL is greater than XC, voltage leads current. Right? Okay, this much is given. We have to calculate the capacitance. Now capacitance find ಮಾಡಬೇಕು. Capacitance find ಮಾಡ್ಲಿಕ್ಕೆ ನೋಡ್ರಿ, first let me draw the phasor diagram here. Phasor diagram ನೋಡ್ರಿ ನಮಗೆ ಈ ತರ ಬರ್ತದೆ. ನೀವು ವೋಲ್ಟೇಜ್ ಟರ್ಮ್ ದಾಗೂ ಫೇಸರ್ ಡಯಾಗ್ರಾಮ್ ತೆಗಿಬಹುದು, ಅಪೋಸಿಷನ್ಸ್ ಟರ್ಮ್ ದಾಗೂ ಫೇಸರ್ ಡಯಾಗ್ರಾಮ್ ತೆಗಿಬಹುದು. See, let me take this one as voltage across resistor. This is voltage across inductor. This is voltage across capacitor. ಇದೇ axis ಮೇಲೆ ನಾ ಕರೆಂಟ್ ಕೂಡ ತಗೋತೀನಿ. Here only I will take current. Right? So voltage across inductor, capacitor as well as resistor. The same phasor diagram I can draw using the oppositions also. Notary, by Ohm's law we know V is directly proportional to resistance. Potential difference is directly proportional to resistance. Andre resistance andre opposition of current. Similarly, voltage will be directly proportional to opposition. Voltage will be directly proportional to resistance. Voltage will be directly proportional to inductive reactance. Voltage will be directly proportional to capacitive reactance. Right? ಅದಕ್ಕೆ ನಮಗೆ ಇಲ್ಲಿ ಏನಾಗ್ತದಪ್ಪ ಅಂತಂದ್ರೆ, see, I can draw the same phasor diagram in terms of oppositions. Voltage across resistor, you take resistance here. Voltage across inductor, you take inductive reactance here. Voltage across capacitor, you take opposition offered by capacitor here. Right? Okay. Next note. ಈಗ ಇಲ್ಲಿ ನಮಗೆ XL ಬಂತು, ಇಲ್ಲಿ XC ಬಂತು, ಇಲ್ಲಿ R ಬಂತು. Correct? We know very well XC is greater than XL. XC is greater than XL. ಹಾಗಾದ್ರೆ XL ಮತ್ತು XC ದ ರಿಸಲ್ಟೆಂಟ್ ಏನಿರ್ತದಲ್ಲ, XC minus XL ಅಂತೇಳಿ, XC minus XL, that will be here. ಆ XC minus XL ನಮಗೆ ಇಲ್ಲಿ ಇರ್ತದ್ರಿ. Why? Because XC is greater than XL. Suppose XL XC ಕಿಂತ ದೊಡ್ಡದಿರ್ತಂದ್ರೆ ಆ ರಿಸಲ್ಟೆಂಟ್ ನ XL minus XC ಅಂತೇಳಿ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ತಗೋತಿದೆ, ಪಾಸಿಟಿವ್ y ಡೈರೆಕ್ಷನ್ ಒಳಗೆ. Okay, now we are having only two vectors. One resistance and another one is XL minus XC minus XL. This much we are having. So the resultant of these both is called impedance. Iveradu the resultant ನಾವು impedance ಅಂತ ಕರೀತೀವಿ. Resultant of these both. ರೈಟ್. ಅದೇ ತರ ಇಲ್ಲಿ ನಮಗೆ ನೋಡ್ರಿ ಎಕ್ಸ್ ಸಿ ಇಸ್ ಗ್ರೇಟರ್ ದನ್ ಎಕ್ಸ್ ಎಲ್ ಇರೋದ್ರಿಂದ ವಿ ಸಿ ವಿಲ್ ಬಿ ಗ್ರೇಟರ್ ದನ್ ವಿ ಎಲ್. ಸೊ ವಿ ಸಿ ವಿಲ್ ಬಿ ಗ್ರೇಟರ್ ದನ್ ವಿ ಎಲ್ ಇಲ್ಲಿ ಬರ್ತದೆ, ರಿಸಲ್ಟೆಂಟ್ ವೋಲ್ಟೇಜ್ ಇಲ್ಲಿ ಬರ್ತದೆ. ಪ್ರೆಸೆಂಟ್ಲಿ ಫಾರ್ ದಿಸ್ ಪ್ರಾಬ್ಲಮ್ ದಿಸ್ ಇಸ್ ನಾಟ್ ರಿಕ್ವೈರ್ಡ್, ಇದು ನಮಗೆ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಇದು ಮಾತ್ರ ನಾವು ನೋಡ್ಕೋಬೇಕು ಈಗ. ಕರೆಕ್ಟ್. ಓಕೆ, ಸೊ ದ ಫೇಸರ್ ದ ಫೇಸ್ ಆಂಗಲ್ ವಿಲ್ ಬಿ ಹಿಯರ್, ಇಲ್ಲಿ ನಮಗೆ ಫೇಸ್ ಆಂಗಲ್ ಇರ್ತದೆ. ರೈಟ್, ದಿಸ್ ಇಸ್ ದ ಫೇಸ್ ಆಂಗಲ್. ಓಕೆ, ವಿ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿಸ್ ಫೇಸ್ ಆಂಗಲ್ ನಾವು. ಈ ಫೇಸ್ ಆಂಗಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ನೋಡ್ರಿ, ಫೇಸ್ ಆಂಗಲ್ ನಮಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ, ಫೇಸ್ ಆಂಗಲ್ ನಮಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ. ವಿ ಗಾಟ್ ಅ ರೈಟ್ ಆಂಗಲ್ ಟ್ರಯಾಂಗಲ್ ಹಿಯರ್, ಇಲ್ಲಿ ನಮಗೆ ರೈಟ್ ಆಂಗಲ್ ಟ್ರಯಾಂಗಲ್ ಬಂತು. ದಿಸ್ ಇಸ್ ದ ಅಪೋಸಿಟ್ ಸೈಡ್. ಅಪೋಸಿಟ್ ಸೈಡ್ ನಮಗೆ ವೈ ಆಕ್ಸಸ್ ಪ್ಯಾರಲಲ್ ಇದೆ. ವೈ ಆಕ್ಸಸ್ ಮೇಲೆ ಏನದ್ರಿ, ಎಕ್ಸ್ ಸಿ ಮೈನಸ್ ಎಕ್ಸ್ ಎಲ್, ಎಕ್ಸ್ ಸಿ ಮೈನಸ್ ಎಕ್ಸ್ ಎಲ್. ದಿಸ್ ಇಸ್ ದ ಅಡ್ಜಸೆಂಟ್ ಸೈಡ್. ಅಡ್ಜಸೆಂಟ್ ಸೈಡ್ ಮ್ಯಾಗ ಏನದ್ರಿ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಅದ. ಕರೆಕ್ಟ್, ರೆಸಿಸ್ಟೆನ್ಸ್. ಓಕೆ, ಸೊ ಪೈ ಇಸ್ ಗಿವನ್. ನೀವು ಪೈ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಈಗ ಸಿ ಫೈಂಡ್ ಮಾಡಬೇಕು, ಕೆಪಾಸಿಟನ್ಸ್ ಫೈಂಡ್ ಮಾಡಬೇಕು. ಸೊ ಕೆಪಾಸಿಟನ್ಸ್ ಫೈಂಡ್ ಮಾಡ್ಲಿಕ್ಕೆ ವಿ ವಿಲ್ ಅಪ್ಲೈ ಟ್ಯಾನ್ ಫಾರ್ ದಿಸ್. ಟ್ಯಾನ್ ಪೈ ಇಸ್ ಈಕ್ವಲ್ ಟು, ಈ ಪೈ ಆಂಗಲ್ ನೀವು ಟ್ಯಾನ್ ಅಪ್ಲೈ ಮಾಡ್ಕೊಂಡ್ರೆ ಅಪೋಸಿಟ್ ಸೈಡ್ ಅಪಾನ್ ಅಡ್ಜಸೆಂಟ್ ಸೈಡ್. ಅಪೋಸಿಟ್ ಸೈಡ್ ಇಸ್ ಎಕ್ಸ್ ಸಿ ಮೈನಸ್ ಎಕ್ಸ್ ಎಲ್ ಡಿವೈಡೆಡ್ ಬೈ ಅಡ್ಜಸೆಂಟ್ ಸೈಡ್ ಇಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ನೀವು ಇದು ಯೂಸ್ ಮಾಡಬಹುದು, ಅಥವಾ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ಪವರ್ ಫ್ಯಾಕ್ಟರ್ ಫಾರ್ಮುಲಾ ಆಲ್ಸೋ. ಕಾಸ್ ಪೈ ಇಸ್ ಈಕ್ವಲ್ ಟು ಆರ್ ಬೈ ಝೆಡ್, ಯು ಕ್ಯಾನ್ ಯೂಸ್ ದಟ್ ಫಾರ್ಮುಲಾ ಆಲ್ಸೋ. ಅದರಿಂದ ನಿಮಗೆ ಆನ್ಸರ್ ಸೇಮ್ ಬರ್ತದೆ. ರೈಟ್. ಓಕೆ, ನೋಡ್ರಿ ಈಗ ನಮಗೆ ವೇರ್ ವಿಲ್ ಐ ಗೆಟ್ ಸಿ ಇನ್ ದಿಸ್ ಫಾರ್ಮುಲಾ. ಸಿ ಅನ್ನೋದು ನಮಗೆ ಎಲ್ಲಿ ಬರ್ತದ್ರಿ, ಎಕ್ಸ್ ಸಿ ಫಾರ್ಮುಲಾ ಒಳಗೆ ಬರ್ತದೆ, 1/2 ಪೈ ಆಫ್ ಸಿ. ಸಿ ವಿ ವಾಂಟ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್. ಸೊ ಈ ಫಾರ್ಮುಲಾ ಒಳಗೆ ನಮಗೆ ಸಿ ಬರ್ತದ್ರಿ. ಸೊ ಈಗ ನಾ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ನನ್ನ ಹತ್ರ ಪೈ ಅದ, ಆರ್ ಅದ, ಎಕ್ಸೆಲ್ ನಾ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು ಈಗ. ಸೊ ಫಸ್ಟ್ ಲೆಟ್ ಅಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಎಕ್ಸೆಲ್. ಲೆಟ್ ಅಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಎಕ್ಸೆಲ್ ಫಸ್ಟ್. Excel, formula of Excel is 2 pi f into L, right? So 2 pi f is 50, f is 50. How much is L? L is 250 millihenry. 250 millihenry, right? 250 milli. 10 to the power minus 3 milliamens. Okay, so let us calculate this. See, it is 2 into pi. Pi means 3.142 into 50 into 50 into 250 into 250. So it is 78550. 78550 into 10 to the power minus 3, or I can simply write it as 7.855 ohm. So this much is the inductive reactance. Inductive reactance ನಮಗೆ ಎಷ್ಟು ಬರ್ತದ್ರಿ. Okay, ನಮಗೆ inductive reactance ಬಂತ. Now using this formula, tan pi formula, I will calculate C now. Okay. Let us calculate C. So using this only we are going to calculate C now. Right? Tan pi, tan 60 degree. Pi namak kottidare. Pi is given. XC we don't know. XC we don't know. XL is 7.855. 7.855. How much is resistance? Resistance is 50 ohm. Resistance is 50 ohm. Correct? So what is the value of tan 60 degree? It is root 3. Root 3 is equal to XC minus 7.855 divided by 50. Root 3 ಅಂದ್ರೆ ನಮಗೆ ಎಷ್ಟ್ರಿ 1.732. It is root 3 into ಈ 50 ನ ಈ ಕಡೆ ತಗೋತೀನಿ into 50 is equal to XC minus 7.855. XC minus 7.855. Correct? So we got root 3. So 1.732 we have taken. Sorry, okay, let us check it as 1.732 only. 1.732 into 50, that is 86.6, right? So this is 86.6. I will shift this 7.855 to this side. So it will be plus 7.855 equal to XC. So idಕ್ಕೆ add madri, add for this, plus 7.855. If you add, you will get 94.455. So XC is equal to 94.455 ohm. This much we got XC now. XC namak best bantu. Initially only we had told XC is greater than XL. XL namak 7.855 bandadre, XC namak 94.455 bandadre. Correct? Now let us calculate C. We want C. ಈಗ ನಮ್ಮ ಹತ್ರ XC ಅದರಿ. We have XC. How much is XC? XC is 94.455, right? 94.455. This is the value of XC. XC the formula ಏನ್ರಿ 1/2 pi FC. 1/2 pi FC. So 94.455. 94.455. I want the value of C. So C is equal to 1 divided by 2 pi. I will take C on that side. 94.455 ಈ ಕಡೆ ಬರ್ತದ್ರಿ. So 2 pi f into 94.455. Correct? Okay, let us multiply all these things. 94.455 into f is 50 into pi is 3.142 into 2. So this will be 29677. So C is equal to 1 divided by 29677.761. Okay, let us divide this. 1 divided by this will take. Okay, 1 divided by 29677.761. Right? How much I will get? 3.36 into 10 to the power minus 5. Okay, I will get it as 3.36 into 10 to the power minus 5. Right? Or I can simply write it as 33.6 into 10 to the power minus 6 farad. Or simply we can write it as 33.6 microfarad. Is nange capacitance bartade. This much will be the capacitance. Right? Okay, so we got to know how to calculate the capacitance in this case. First now ಏನು ಮಾಡಿದ್ವಿ Excel we have calculated using the phasor diagram. Tan pi is equal to ತಗೊಂಡು pi value ಕೊಟ್ಟಿದ್ದಾರೆ substitute ಮಾಡಿ we have simplified and we have found XC. Using XC we have calculated capacitance, right? So we got to know how to calculate capacitance. Okay, let us go to the last question then. See, last question is on dual nature. See, ಇಲ್ಲಿ ಒಂದು ಸ್ವಲ್ಪ model question paper 3 ಒಳಗೆ changes ಮಾಡಿದ್ದಾರೆ. Model paper 1, model paper 2. ಎರಡು model paper ಒಳಗೆ you have 5 mark numerical on ray optics. Dual nature ಮೇಲೆ 5 mark numerical ಇರಲಿಲ್ಲ. ಇದು ಒಂದು model paper ಒಳಗೆ ಥರ್ಡ್ model paper ಒಳಗೆ ಮಾತ್ರ ನಮಗೆ ray optics ಮೇಲೆ numerical ಕೇಳೋ ಬದ್ಲಿ 5 marks ದ dual nature ಮೇಲೆ numerical ಕೇಳಿದಾನೆ. So there is, I can say it like this, there is 75% of chances to get numerical from ray optics, and in that place only there is 25% chances to get a numerical on dual nature. So total 4 numericals ಬರ್ತಾವೆ. So first numerical ನಿಮಗೆ ಟಚ್ ಆಗಬೇಕಾದ್ರೆ first chapter and second chapter you will touch first numerical. Current electricity second numerical, alternating current third numerical, fourth numerical ನೀವು ಟಚ್ ಮಾಡಬೇಕಾದ್ರೆ ray optics and dual nature both you have to do. So what I recommend is first chapter, second chapter, third chapter and seventh chapter AC. Electric charges and field, electric potential and capacitance, current electricity, alternating current. ಈ 4 chapter ಮೇಲೆ numericals ಮಾಡ್ರಿ 2 at any constituent touch. ಹೆಂಗೋ ಎರಡು numericals ಅಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡೋದಿರ್ತದೆ. Any 2 we have to solve. So ಎರಡು ನಿಮಗೆ 100% ಟಚ್ ಆಗ್ತವೆ. Okay, let us solve this then. See, when a light of wavelength 400 nanometer is incident on a photosensitive surface, the stopping potential for the photoelectrons emitted is found to be 0.96 volt. Okay. When light of wavelength 500 nanometer is incident on the same photosensitive surface, the stopping potential is found to be 0.34 volt. Okay. Calculate the Planck's constant. Given speed of light is this much, electronic charge is this much. Okay. ನಮಗೆ ಎರಡು ವೇವ್ಲೆಂತ್ ಕೊಟ್ಟಿದ್ದಾರೆ. The first wavelength is 400 nanometer. 400 nanometer. And when the wavelength of 400 nanometer is incident, how much is the stopping potential? How much is the stopping potential? 0.96 volt. Okay, stopping potential number 1, 0.96 volt. When the second light of wavelength 500 nanometer, 500 nanometer is incident, stopping potential number 2 is 0.34 volt. 0.34 volt. Right? What they are asking us to calculate the Planck's constant. Planck's constant value ನಮಗೆ already ಗೊತ್ತದ 6.62 into 10 to the power minus 34 joule second. Ist answer ನಮಗೆ ಬರಬೇಕು. This much answer we have to get. Okay, let us solve it then. See, we know very well the relation between kinetic energy, I mean the maximum kinetic energy and stopping potential is like this. EVS, right? ಈಗ ನೋಡ್ರಿ by Einstein's equation we know very well. ನೋಡ್ರಿ Einstein's equation ಹೆಂಗದೆ? Energy of a photon is equal to work function plus maximum kinetic energy. This is Einstein's equation. Then maximum kinetic energy will be equal to energy of a photon minus work function. Energy of a photon minus work function. See, ಈಗ ಈ ಎರಡು ಕೇಸ್ ಒಳಗೆ ನಮ್ಗೆ ಏನ್ ಮಾಡಿದಾರೆ? Only the radiation, wavelength of the radiation has been changed. Metal surface ಅದು ಐತ್ರಿ. ಫಸ್ಟ್ ಒಮ್ಮೆ 400 nanometer ರೇಡಿಯೇಷನ್ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿದ್ದಾರೆ, ಅವಾಗ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಶಿಯಲ್ ಬೇರೆ ಇದೆ. ಅದೇ ಮೆಟಲ್ ಮೇಲೆ ಮತ್ತೊಮ್ಮೆ 500 nanometer ರೇಡಿಯೇಷನ್ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿದ್ದಾರೆ, ಅವಾಗ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಶಿಯಲ್ ಬೇರೆ ಇದೆ. ಸೊ ಮೆಟಲ್ ಏನ್ ಚೇಂಜ್ ಮಾಡಿಲ್ಲ, ಬರೀ ಏನ್ ಚೇಂಜ್ ಮಾಡಿದಾರೆ? ರೇಡಿಯೇಷನ್ ವೇವ್ಲೆಂತ್ ಚೇಂಜ್ ಮಾಡಿದ್ದಾರೆ. ಮೆಟಲ್ ಹ್ಯಾಸ್ ನಾಟ್ ಬಿನ್ ಚೇಂಜ್. ಮೆಟಲ್ ಚೇಂಜ್ ಆದ್ರೆ ಮಾತ್ರ ವರ್ಕ್ ಫಂಕ್ಷನ್ ಚೇಂಜ್ ಆಗುದು. ವರ್ಕ್ ಫಂಕ್ಷನ್ changes only when metal changes. So here we have not changed the metal. ಅಂದಮೇಲೆ ವರ್ಕ್ ಫಂಕ್ಷನ್ ನಮಗೆ ಇಲ್ಲೂ ಅಷ್ಟೇ ಇರೋದ್ರಿ, ಈ ಕೇಸ್ ಒಳಗೂ ಅಷ್ಟೇ ಇರೋದ್ರಿ, right? Okay, let us apply this formula. We know very well kinetic energy, maximum kinetic energy is equal to energy of a photon minus work function. Correct? Energy of a photon minus work function. Okay, maximum kinetic energy ನಮಗೆ ಏನು ಫೈಂಡ್ ಮಾಡೋದ್ರಿ? Potential energy. Okay, maximum kinetic energy means I can take it as E into Vs. ಇದನ್ನ Planck's constant we have to find, right? Okay, ಇದನ್ನ E into Vs ಅಂತ ನಾನು ತಗೋತೀನಿ. E is energy. Energy means it is given by hc divided by lambda. Energy of a photon, hc divided by lambda. Okay, let work function be as it is. Correct? Okay, here I will take it as Vs1, first stopping potential, and I will take it as lambda 1, first wavelength. Like this we will take it. Apply the same formula for the second set. For the second set, I will apply the same formula. Ke max is equal to, it will be E minus W. Ke max ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ನಾ ಇದನ್ನ E into Vs2 ಅಂತ ನಾ ತಗೋತೀನಿ. E into Vs2, here it is E into Vs1, right? Energy hc divided by lambda 2 I will take. This time wavelength is different, but work function is not different. ಇಲ್ಲಿ W1 W2 ತಗೋಬಾರ್ದು, ಎರಡು ಕಡೆ W ನ ತಗೋಬೇಕು. Why? Because we have not changed the metal. Metal ನಾವು ಬದಲಾಯಿಸಿಲ್ಲ. Correct? Okay, now what we will do, we'll subtract both the equations. Let us subtract both the equations. If we subtract, we will get it like this: E Vs1 minus E Vs2. LHS, RHS subtract ಮಾಡ್ಕೊರಿ. Okay, hc divided by lambda 1 minus W minus hc divided by lambda 2 minus into minus plus work function, right? So minus work function plus work function will get cancelled. Here I will get it as E into the bracket Vs1 minus Vs2 equal to, here if I take hc common in the bracket, I will get 1 by lambda 1 minus 1 by lambda 2. Okay, now let us simplify this. Okay, ಇಲ್ಲಿ ಮತ್ತೊಂದು ಸ್ಟೆಪ್ ನಾವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಂಡು ಬರ್ಕೊಳ್ಳೋಣ. E Vs1 minus Vs2 is equal to hc. Here it will be lambda 2 minus lambda 1. Cross multiply ಮಾಡ್ಕೊರಿ. Lambda 2 minus lambda 1 divided by lambda 1 into lambda 2. Okay, now go on substituting the values. Values go on substitute ಮಾಡ್ರಿ. E into the bracket. How much is Vs1? Vs1 is 0.96. Okay, 0.96. How much is Vs2? It is 0.34. 0.34 equal to hc. We'll keep it as it is, hc into the bracket lambda 2 minus lambda 1. 500 minus 400. So it will be 100 nanometer. 100 nanometer. Nano andre 10 raised to minus 9. Sorry, multiply ಮಾಡ್ಕೊಳ್ತೀವಿ. So nano into nano, it will be 10 raised to minus 18. Minus 9 into minus 9. 500 into 5. Sorry, we are subtracting. Okay, we are subtracting. See, 500 nanometer minus 400 nanometer will be 100 nanometer. Nano means 10 to the power minus 9. Divided by, we are multiplying now lambda 1 into lambda 2, 400 into 500. So it will be 2 lakh. It will be 2 lakh into nano, 10 to the power minus 9 into 10 to the power minus 9. So it will be 10 to the power minus 18. Correct? Okay, so we'll simplify this again. ಇದನ್ನ ನಾವು simplify ಮಾಡ್ಕೊಳ್ಳೋಣ. Okay, so we'll get it like this. See, it is 0.96 minus 0.34, 0.62. So this is 0.62. In idu HC. So what I will get is 00 from here, 00 from here will get cancelled. 10 to the power minus 9 from this and 10 to the power minus 9 from this will get cancelled. So I will get it as 10 to the power minus 9 ಇಲ್ಲಿ ಏನು ಉಳಿದಿರ್ತದ ಅದನ್ನ ಮೇಲ್ಗಡೆ ತಗೋತೀನಿ. 10 to the power plus 9 divided by, we are having 2000 here, 2000. Okay, I will take it like this now. HC is equal to ಬರ್ಕೊಂಡ್ರೆ ಇದು E into 0.62 into 2000 I will get, into 2000 divided by 10 to the power 9. 10 to the power 9. So what is the value of E? E means it is 1.6 into 10 to the power minus 19. So 1.6 into 0.62 into 2000. So this is 1984. So 1984 into 10 to the power minus 19. 10 to the power minus 19 divided by 10 to the power plus 9. Correct? ಓಕೆ, ಈಗ ಇಲ್ಲಿ ಎಚ್ ಸಿ ಅದ, ಐ ವಿಲ್ ಟೇಕ್ ಇಟ್ ಆಸ್ ಎಚ್ ಸಿ, ಐ ವಿಲ್ ಟೇಕ್ ಟು ದಿಸ್ ಸೈಡ್. ಈ ಕಡೆ ನಾ ಸಿ ತಗೋತೀನಿ. ಸಿ ಅಂತಂದ್ರೆ ಅದರದ ವ್ಯಾಲ್ಯೂ ಏನ್ರಿ? ಸಿ ಮೀನ್ಸ್ ಇಟ್ ಇಸ್ 3 into 10 raised to 8 ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟ್. 3 into 10 raised to 8 I will get it as correct. Okay, so finally I will get it as 1984 into 10 to the power minus 19 divided by 3 into 10 to the power 9, 10 to the power 8 will be 10 to the power plus 17. Okay, 1984 divided by 3. So this will be 661.3 into 10 to the power minus 19. ಇದು 10 to the power 17 ಮೇಲ್ಗಡೆ ಬಂತಪ್ಪ ಅಂತಂದ್ರೆ minus 19 minus 17 will be minus 19 minus 17 will be 10 to the power 36. 10 to the power minus 36 it will be. Correct? Or I can simply write it as 6.61 into 10 to the power minus 34 joule second. So this much will be the value of H. Planck's constant value ನಮಗೆ ಅಷ್ಟು ಬೇಕತ್ತೆ, that we have got. Right? This is how we have to calculate the value of Planck's constant. So by this we have completed the 5 mark numericals from model paper 1, model paper 2 and model paper 3. Right? Dear students, I hope you understood, and if you like the content of this channel, please don't forget to subscribe and share the channel, share the videos. Right? If you need anything else, please put a comment. I will surely make a video on that. Please keep watching and supporting this video. Please keep supporting the channel. Right? Thank you so much for watching till the end. Please keep watching and supporting the channel. Thank you.